This chapter traces how an internal Palantir practice turned into a broader Silicon Valley habit. The focus is on where the idea came from, why it spread, and what changed when a company method became a default way of working. Palantir began with a sales problem that was really a delivery problem. The customer could not be understood, evaluated, or served from a distance. That constraint shaped the role that later became the FD. The important thing to hold on to is that the role did not start as a neat job description. It formed because the customer environment imposed limits that ordinary software selling could not handle. Government and intelligence buyers were dealing with sensitive, compartmentalized data and tightly controlled access. A polished demo and a trial license assume openness. These customers lived inside the opposite conditions, so the usual enterprise motion broke down immediately. The next question is why the standard playbook failed so completely. The answer sits in the gap between how ordinary software gets evaluated and how these customers were allowed to work. A standard sale quietly depends on openness, open access, representative data, and a stable problem that can be explained ahead of time. Once any of those assumptions fail, the whole motion starts to wobble. If outside teams cannot enter the room freely, then the earliest part of selling already changes. Trust and clearance come before persuasion. Representative data is often what makes a demo credible. When the real data is sensitive, that shortcut disappears, and the product has to prove itself under much tighter conditions. Slides work when the problem is already legible. In these environments, the problem was still being uncovered while the software was being evaluated, so a scripted show could not carry the weight of proof. In ordinary enterprise buying, those steps can happen one after another. Here, they were tangled together, which meant the company had to solve access, credibility, and technical fit at the same time. That is why the first meeting was rarely about features. The work had to begin with trust, with permissions, and with a path into the customer's actual data and workflow, because only then could the software be judged honestly. The lesson is simple but important. The constraint was not a preference, it was structural. If the environment blocks normal evaluation, the sales motion has to change with it. Once the environment is clear, the data itself becomes the next issue. Sensitive data is not one thing, and the differences matter for how software gets built and adopted. It helps to be specific about what made the data hard to work with. The challenge was not just privacy, it was the operational cost of making a mistake. Three traits show up again and again. A mistake can change an outcome. The useful information is scattered across many systems, and not everyone who needs the software is allowed to see everything behind it. That combination makes evaluation and deployment much harder than a normal product review. A mock dataset can hide the real difficulty. If the software only works on cleaned-up samples, it has not yet proven anything about the messy permissions, messy integrations, and messy workflows that define the actual job. That is why the role boundary starts to shift. A salesperson can describe the end state, but an engineer is the one who can enter the customer's constraints and show whether the system really works there. At this point, the role logic becomes visible. Once the customer environment cannot be abstracted away, selling and implementation start to merge into one delivery motion. Someone has to learn the problem, get through the security constraints, build the first working version, and respond to what happens in practice. Those tasks stop being separable when the product depends on the environment. That role is the ancestor of the modern FD. The title comes later. The underlying need is already there. Early field engineers were not just pre-sale support with deeper technical skill. They translated between customer reality and product reality, built the first usable version, and stayed close enough to the mission to change the system as they learned. The reason the model mattered is that the usual sales structure could not do all of that at once. The work required someone who could both understand the use case and shape the product around it. The customer could not fully judge the software without being inside a protected environment, and the seller could not learn the use case well enough from afar. That is the core mismatch the field team had to close. The first useful version had to fit the real system, not an idealized one. That means adapting to the actual data structures, the actual permissions model, and the actual mission pressure the customer lived under. Adoption was measured by whether the tool entered real work. Approval in a meeting does not count if analysts and operators never trust the system enough to use it on live tasks. Every deployment also became a source of product insight. Data ingestion, entity matching, permissions, interface design, and operational constraints all came back as lessons for the next engagement. That feedback loop is the heart of the origin story. Engineers were not added as decoration around sales. They were the mechanism that made the sale possible in the first place. A useful way to read the early model is through mission-type tactics. Give the team the objective, constrain the boundary conditions, and let the people closest to the problem act quickly. That style of work explains why autonomy became so important. The team needed a clear goal, a tight set of limits, and room to make decisions on the ground. That combination is what lets a small group move in a hard environment without waiting for every answer to come from the center. Autonomy was not a philosophy statement. When workflows failed or data shapes changed, the person on site had to adjust the interface, repair the integration, or reshape the workflow without waiting for a long approval chain. That same structure is why the modern FD looks the way it does. The role is built for situations where the product must adapt while the customer problem is still being clarified. At the start, nobody has the whole map. The job is to learn the problem while working on it, not after everything has already been neatly defined. The environment is not a backdrop. It is part of the product requirements. If the system cannot fit the data, the permissions, and the workflow, then the deployment fails no matter how polished the software looks elsewhere. Real learning starts when the tool is in the hands of actual users. That is when hidden constraints, workflow friction, and adoption issues show up clearly enough to change the product. The practical pattern can be stated cleanly now. The important thing is to compare a normal enterprise motion with the field-driven motion Palantir had to invent. A table works well here because it turns a messy historical story into a usable comparison. Keep the contrast in mind as the chapter moves from the early model to later FD variants. Read the left and right sides as two different operating assumptions. One depends on distance and polished evaluation. The other depends on embedded work inside the customer's actual environment. That is the structural shift in one line. The field engineer was not a sidecar to sales support. The field engineer became the process that made adoption possible. The model did not stay confined to one company or one moment. Once the pattern works, it starts to look like a reusable template for a whole class of difficult customers. The broader lesson is that some environments force product judgment, technical execution, and customer discovery into one tightly coupled team. When that happens, the pattern stops looking like a workaround and starts looking like a category. That is why Palantir matters as a starting point. These customers could not be convinced by abstraction alone. The software had to be worked into their context before the value became visible. The job market implication is secondary, but clarifies why the role persists. As long as software enters sensitive, messy, mission-critical settings, companies need people who can bridge product, engineering, and the customer's operating reality. The same logic becomes even more visible once AI enters the stack. The hard part is no longer just selling software into the environment. It is placing a model inside a workflow without breaking that workflow. LLM application architecture is about the parts that make an AI system usable in practice. What data it can see, how tools are routed, where a person reviews output, and how failures are handled. In a sensitive environment, the real question is whether the model can live inside the workflow safely. Once you name the moving parts, the bridge from early Palantir work to modern AI deployments becomes straightforward. The same integration problem is still there, just with more complex components on top. Workflow design means deciding which steps belong to a person and which belong to the model, then defining the handoff between them. A human might approve or escalate. The model might draft, classify, retrieve, or summarize. Shipping AI now depends on explicit tests, not just a convincing demo. Evals have to show that the system meets the conditions that matter: accuracy, latency, refusal behavior, and failure handling. An AI agent that can take actions needs both reliability and governance. Reliability asks whether it works consistently. Governance asks whether it is allowed to act on that data, under that policy, with that audit trail and that level of human oversight. The underlying logic has not changed. Product, environment, and deployment team cannot be separated for long. Once AI touches real data and real decisions, someone has to handle discovery, architecture, testing, rollout, and feedback. A clean way to hold the comparison is to track how the hard problem changes from one era to the next. The role stays similar. The technical surface changes. In the early Palantir era, the challenge was simply getting software into a protected, mission-critical space where normal evaluation would not work. In modern deployments, the challenge is getting an LLM into that same kind of environment without creating a security, reliability, or a governance problem. In both cases, the useful person is the one who can turn customer need into a system that works and then bring deployment reality back into product decisions. That is the enduring shape of the role. A second comparison makes the role even clearer. The point is to separate what the field team has to do before deployment from what it keeps doing after the system is live. Read this as a workflow map. Before deployment, the job is discovery and first contact with the constraints. After deployment, the job becomes refinement, hardening, and long-term fit inside real operations. That is the deeper lesson to carry forward. The FD is not just a salesperson with technical skills or an engineer with customer empathy. It is a response to the fact that some software must be proven in context, not in a showroom. The practical rule is straightforward. When the buyer cannot safely evaluate the product from a distance, engineering becomes part of the go-to-market motion. That sets up the next step, where this necessity turns into an internal identity and a named role. The focus here is how a role called FD came into being, not as a clever label, but as a response to a hard deployment problem inside Palantir. That origin matters because it explains why the job looks the way it does today. The starting point was practical. Small teams were being asked to work on sensitive customer problems, and the company needed a way to describe the people who could operate in that environment effectively. That question gets to the heart of the origin story. Before the public title existed, there was already an internal identity, and that internal name helped show that the role was real before it was widely named. The internal names point to something important. These engineers were not just classic product builders. They were expected to work near the customer, inside the customer's data and workflow, where the software had to succeed in practice, not just in theory. That gap is the whole story. A platform feature only matters if it can be shaped into something an organization can actually adopt, and the Delta's work was to make that translation happen. The role becomes easier to understand when you compare what a deployment looked like before and after someone with that responsibility got involved. A comparison makes the function concrete. Before the field engineer shows up, the organization may have data, urgency, and a promising demo, but not yet a working path to production. The list that follows is the common precondition. The raw pieces are there, but they are not yet connected into a usable system. Data fragmentation is often the first obstacle. If the information lives in separate systems, the team cannot easily trust it, join it, or use it in one workflow. Domain experts usually know the problem well, but that knowledge does not automatically become requirements. Someone has to turn the operational pain into something software can actually solve. A demo can hide a lot. Once the tool meets the real day-to-day process, friction appears immediately if the workflow assumptions are wrong. That last mile is where many pilots die. A prototype can look finished while still lacking the ownership, integration, and iteration needed to survive in production. Once the field engineer is involved, the work stops being vague support and becomes a structured process of discovery, adaptation, and feedback. The first shift is in framing. The engineer asks what decision the system should improve, who depends on it, and what is preventing adoption, instead of treating the work as a simple feature request. The second shift is specificity. The software has to fit the customer's actual data, interfaces, workflows, and constraints, which often means building or modifying pieces rather than using a generic template. The third shift is reuse. Real deployment reveals what breaks, what users ignore, and what should be generalized so the next customer benefits from the same lesson. That combination is why the role is larger than field support. The engineer is building, translating between technical and operational language, and discovering problems the product team would otherwise miss. That scale clue suggests something structural about the company. When the field side is larger than the core product side, the organization is oriented toward deployment and operational adaptation, not just software creation. That ratio explains the early identity of the role. The company was already behaving less like a conventional software vendor and more like a team built to move software into real organizations and make it work there. The internal name makes sense once you look at the kind of work the role demanded. Fast movement, judgment in the field, and the ability to operate with a mission-style mindset. The internal label matters because it points to a pattern that other companies would later recognize and reuse. Three themes keep showing up in that pattern. A durable role usually comes from necessity. If the job exists because the work demanded it, not because someone invented a catchy title, it tends to survive and spread. Field teams need room to move. If every adjustment has to wait for approval from headquarters, the team loses the speed and judgment that the role is supposed to provide. That autonomy is not about working alone. It is about adapting in real time. On site, the engineer has to revise the plan as the customer's environment reveals new constraints. That is why the role is so useful in practice. The engineer learns from the live workflow, spots the mismatch between the tool and the task, and turns those observations into better deployment decisions. The output is not just code. It is a working bridge between the technical system and the human process around it, with careful decisions about automation, human oversight, and handoff. That logic became even more important in AI-native products. Once models sit inside customer workflows, the real challenge is deployment discipline. Choosing the workflow, controlling failure modes, verifying decisions, and measuring whether users actually benefit. The public title spread only after the underlying operating model had already proven itself. The name followed the practice. That order matters. First, the work became visible, then the name became portable enough for other people and companies to use. The public phrase made the role easier to explain outside Palantir. Compared with the internal code name, it tells outsiders that the engineer is deployed close to the customer and expected to work in the field. Other companies copied the model because they ran into the same constraint. When the environment is messy and important, software cannot just be handed off. Builders have to stay close enough to adapt the product to reality. The badge may change from company to company, but the job often stays the same underneath. Product judgment, technical execution, customer discovery, and deployment ownership all sit in the same role family. That is the important ordering. The work existed because the customer problem demanded it, and only later did the company language catch up and give it a stable name. Palantir works as an early template because it combined the ingredients that later adopters would need in different proportions: speed, access to users, custom software, and difficult data at scale. The list that follows is not random. Each item describes a condition that makes field deployment work necessary in the first place. Small teams reduce the drag of coordination. That matters when the customer problem is changing quickly and the engineer needs room to react. Direct access to the people who use the system shortens the feedback loop. Without that access, the engineer has to guess at what the real problem is. Custom apps matter when the workflow is too specific for generic software. The solution has to match a particular operation, not an abstract category. Large data environments raise the stakes. At that scale, small mistakes become expensive, so correctness and performance are not extras. They are part of the product itself. End-to-end ownership is what ties the job together. The engineer has to move from discovery to deployment and keep iterating until the system actually works in practice. That combination is why the Delta role lasted. It was never just support. It was product work embedded inside the customer's operational reality. For a hiring manager or job seeker, that is the right test. If the team really owns the gap between software and deployment, and the engineer can change the customer outcome, then you're looking at the same family of work. The larger point is simple. The company did not invent a trendy hybrid title first and then search for a job to match it. It named a role that customer reality had already forced into existence, and then built its operating model around that reality. The distinction here is between a metaphor that sounds dramatic and one that actually describes how responsibility is split. The forward-deployed idea makes sense only if the field has real judgment and headquarters still defines the mission. In literal military language, forward is the place closest to where events are unfolding, while rear echelon sits farther behind the line and handles support, planning, and logistics. That same distance is what matters in an FD role. Distance from headquarters and distance from the customer's real environment. The phrase is narrower than those common misreadings. It does not mean the engineer is in combat, and it does not mean a vague consultant or a technical support rep with a different title. It means the people closest to the problem are trusted to make tactical calls while the center keeps the mission and constraints clear. That is where the comparison stops being decorative. It starts to describe who decides what, how quickly the field can respond, and how much authority sits near the customer problem. Auftragstaktik, or mission-type tactics, is the logic behind the metaphor. Headquarters sets the objective, the intent, and the boundaries. The field unit figures out how to accomplish the mission under local conditions. That works because the environment changes too fast for every decision to wait for permission. That pattern is the operating instinct behind the role. An FD is built for a world where local judgment matters and a slow permission chain would get in the way of the work. The split becomes clearer when you compare strategic direction with execution. The center stays responsible for the goal, while the field owns the way the goal gets translated into action near the customer. A traditional software organization usually pushes decisions upward and downward through layers. Customer-facing teams report problems, central teams decide implementation, and deployment happens on a schedule controlled far from the customer site, which leaves little room for local adaptation. A mission-type model keeps the guardrails at the center: strategy, quality, security, and standards. Once the objective is set, the field team chooses the tactical path because it can see the operational reality and react faster than headquarters can. That is why the comparison survives. It names a real division of responsibility instead of just giving the team a dramatic label. The center still defines the target. It sets the standard for success, so the field team is not inventing its own mission or drifting away from the product's purpose. Once the target is clear, the embedded engineer chooses the path that fits that customer's environment. That autonomy matters because the best tactic in one account can fail in another. The feedback loop is what makes the role strategic. A good field team does not only solve the immediate issue, it turns what it learns into changes that improve the product for the next deployment. A simple comparison helps fix the difference in memory. The real distinction is less about technology and more about where judgment lives. On one side, headquarters owns the goal and most of the implementation detail. On the other, headquarters supplies the objective and the field adapts the execution, sees the customer reality directly, and pushes that learning back into the product. Palantir's early field teams are a strong example because the work matched the theory. The engineer was close enough to the operational user to see messy data, urgent constraints, and the gap between a model on paper and a system people could trust. That placement changed the job itself. Instead of waiting for requests to move through account management, the engineer saw the problem directly and worked against the conditions of use, not an abstract description of them. Once the team is embedded, the work splits in a useful way. The customer brings the operational context, and the engineer turns that context into something workable. Before the embedded engineer arrives, the problem often looks fuzzy and scattered. Afterward, the team can narrow it, connect data sources, shape a thin workflow, and keep iterating until the tool fits the day-to-day job. The technical build matters, but the deeper advantage is visibility. The team can see what breaks, what changes, whether adoption improves, and what new knowledge should go back to the core product group. First, the team sees the failure itself. That matters because a problem described secondhand often hides the real bottleneck. Then the team can connect a specific intervention to a specific effect. That makes the work measurable instead of anecdotal. Adoption tells you whether the solution survived contact with the workflow. A good idea that nobody uses is not operational value. Finally, the lesson moves back to the product team. That upstream learning is what keeps the role from becoming one-off custom work. That feedback loop is the real payoff. The field team is not just shipping a custom fix. It is gathering evidence about how the product ought to evolve. A practical example makes the autonomy easier to see. The question is not whether the engineer follows instructions, but whether the engineer can adapt the mission to the shape of the actual work. Imagine a team trying to summarize incident reports and route them to the right owner. The first attempt often fails because the inputs are messy, the output format is unstable, and the workflow does not match how the team really triages work. A rear echelon approach would slow everything down. The team would wait while requirements get rewritten and approvals move upward instead of fixing the workflow where the problem actually appears. A forward-deployed team acts closer to the work. It watches the handoff, removes friction locally, and chooses the smallest change that makes the system usable. Better extraction, selective human review, a better interface, or a tighter evaluation set. That is mission-type tactics translated into software work. The strategy stays fixed. The method changes because the field team can see what the environment demands. The same structure shows up in modern AI work, especially when LLMs move from demos into production. The scope is broader, but the core task is still to connect a model to a real operational workflow without losing control of the system. The terms need to stay precise because AI teams often mix product design, system design, and operations into one conversation. Clear definitions keep the metaphor useful instead of vague. Discovery means finding out what the customer is actually trying to accomplish, not just copying the feature request. That shift matters because the request is often a symptom, while the real task is the thing the team needs to get done. Architecture is a shape around the model. Prompts, retrieval, tools, routing, memory, interfaces, and fallbacks. An FD often has to decide how those pieces fit together so the model behaves well in the real workflow. Workflow design means deciding what the model should do, what a person should do, and where review belongs. That division is often the difference between a prototype and a system people trust. Deployment should be tied to measurement, not optimism. If you cannot evaluate realistic cases, you cannot tell whether the system is helping or just producing convincing outputs. Reliability and governance keep the system useful without letting it become unpredictable or overprivileged. In practice, that means limiting actions, preserving auditability, and making failure modes visible before they become incidents. An FD in AI sits right at that junction. The work is to understand the operational task, shape the workflow around the model, test failure modes, decide what actions are allowed, and keep a loop open to the product team. That is why the role spread beyond defense and intelligence. Once companies moved from demos to deployment, the difficult part was often the last mile, fitting the model into a real workflow, making it trustworthy, and proving that it actually changed behavior. A before and after comparison makes the shift easier to see. The same underlying technology behaves very differently once the field team takes ownership of the problem framing and the rollout. The same technology looks different once the field team owns the framing and the rollout. The shift is from vague interest to a specific workflow, from a generic prototype to an embedded solution, and from anecdotal success to measurable operational impact. That table is the military metaphor translated into business language. Headquarters supplies the mission intent, and the field converts that intent into usable reality. For readers coming from SaaS, AI, or enterprise software, the military language can sound grander than the work deserves. Resist that reading. The point is precision about authority, proximity, and learning, not prestige. That is the right way to keep the comparison grounded. The metaphor matters because it names structure clearly, not because it dresses the job up. It points to three habits that can otherwise look like personality traits. Once those habits are named, the role becomes much easier to understand. Field autonomy means local decisions happen quickly. Tight customer proximity means the engineer learns from direct observation rather than secondhand reports. Continuous learning back to headquarters means every deployment improves the next one. That combination is what later chapters keep returning to. An FD is not just a traveling engineer or a slightly upgraded architect. It is a role built around ownership at the edge of the organization. For a career lens, the important question is whether the team truly grants autonomy. Can the person shape the solution, influence deployment, and send product learning upstream? If not, the title may be borrowing the language without the operating model. The next step is to ground this doctrine in lived experience. The focus shifts to what the work felt like inside early Palantir field teams, day by day, while the model was still being proven. Early Palantir field work was about sitting close to a customer's problem and turning pressure into something usable. The point here is the tension between rapid delivery and messy reality. Real data, real deadlines, and no room for hand-waving. The contradiction is that everyone wanted speed, but the work itself was usually slow and disordered at the start. That gap between expectation and reality shaped the whole day. One group is already talking about deliverables and Friday, while another is still figuring out what the data even means. The engineer in the middle has to translate between those worlds and keep moving even before the system feels clean. That model put small teams right beside the user, so the job was to build something real rather than offer advice from a distance. Titles varied over time, but the core role stayed the same. Stay with the problem long enough to see whether the solution actually worked in practice. The work mixed technical judgment with product intuition and a lot of adaptation. A good field engineer had to find the shape of the problem quickly, get a first version into use, and then carry those lessons back into the product itself. The real pattern was a tight loop between customer needs and product improvement. The point here is not just what work was done, but how quickly the engineer moved from listening to fixing to feeding lessons back into the system. The details become clearer when you follow one day from start to finish. Each stop in the sequence answers a different question: what the customer needs, what is broken, what can survive production, and what should change upstream. Morning work was about talking to the people who would actually depend on the system. The conversation was rarely abstract. It usually turned into a sharp discussion about one analyst, one operator, or one manager and the exact outcome they needed. By midday, the assumptions met reality. Bugs often came from permissions, messy data, or a workflow that looked neat on paper but did not match how people really worked. Afternoon effort was about making the thing survive real use. That could mean adding logs, tightening reliability, redesigning a step, or admitting the first idea was not the right one and replacing it. At the end of the day, the job was to turn field experience into direction for the core team. The questions were simple but important. What did people need? What feature was missing? And what were they already rebuilding by hand? That distinction explains the difference an FD could make. The target was a usable application, a measurable change in workflow, and a clear path from customer pain back into product decisions. The memorable part here is not just the title or the job description, but the lived experience around it. The details about money, culture, and decision-making show what the role felt like from the inside. Some of the early pay packages sounded attractive until stock movement changed the picture and options slipped underwater. At the same time, the workplace had a very specific internal energy, intense, narrow, and full of private jokes and traditions that made the team feel like its own world. Those phrases capture two sides of the same culture. One points to the odd, insider humor people associated with the company, and the other describes a way of working where you argue firmly, but you stay ready to change course when evidence changes. The point of those stories is not the gossip itself. They reveal a setting where engineers had to make local calls fast, talk directly with non-engineers, and keep adapting when the original plan stopped fitting the situation. That is the deeper lesson from the public accounts. The job was really about bridging the distance between what existed and what the customer needed it to become. And that meant taking responsibility for the mismatch instead of waiting for perfect instructions. The point here is that an FD was solving an open-ended problem, not just carrying out a fixed rollout. That difference changes how the role works, how much judgment it needs, and why it mattered so much later. That comparison misses the real distinction. The job was broader than technical delivery because the engineer also had to understand the problem well enough to shape the solution itself. Traditional implementation work starts from a defined scope: configure, adapt, train, handoff. Field work at Palantir asked for something closer to exploration, where the engineer had to uncover the real workflow, find the bottleneck that mattered, and then build around that bottleneck. That combination is what made the role a precedent. Product discovery, operational decision-making, and long-term delivery were usually split across different teams, but the field engineer had to carry all of them at once. The first task was finding the pain point worth solving. If the team picked the wrong problem, even a well-built tool would miss the real need. The engineer got a broad objective and then acted locally. That meant making useful moves without waiting for constant permission from a central team. Autonomy mattered because headquarters could not see every detail on the ground. The person in front of the customer had to make judgment calls with incomplete information. Ownership did not stop at a prototype. The same person often had to carry the work into production use and stay responsible for what happened after the first demo. Speed mattered because the customer needed something useful early enough to trust the effort. A quick win could reveal whether the direction was right before too much time was spent. Getting a demo to work is one thing. Making it reliable enough for real operations is another. That transition usually exposes the hidden engineering and process work that prototypes leave out. The solution also had to survive after the field team left. That required documentation, transfer, and enough institutional support that the work did not vanish with the people who built it. Those labels describe the same pattern from different sides. Once you see that, the role stops looking like ordinary implementation and starts looking like a much more complete way of delivering software into the real world. A short field vignette can make the role feel concrete. Not a theory exercise, but a pattern of work that starts with a user problem, meets messy constraints, and ends with a tool people actually use. The example is composite, built from public practitioner accounts, so it shows the shape of the work without tying it to one real client. That makes it useful for seeing the common pressures an FD runs into. A request like build a dashboard often hides several harder problems at once. The data may live in separate systems. The rules around access may be strict, and the users may care much more about cases and deadlines than about dashboard terminology. That is why the first move is to sit with the people doing the work and understand what decision they are trying to make. A rough first version is enough if it connects the right data, answers one painful question, and fits into the real workflow. After deployment, the evidence comes from daily use. Fewer exports to side spreadsheets, faster workflows, and signs that the tool is part of ordinary work rather than a demo. The follow-up report then becomes a map of what to fix, what to keep, and which assumptions did not survive contact with the field. That loop is what turns a prototype into a useful system and turns user contact into product understanding. The origin story is not a single clever build. It is the repeated cycle of listening, adapting, and proving value in the work itself. Palantir's field delivery model made a new operating pattern easy to see. Technical people stayed close to a live customer problem and carried responsibility through delivery. That matters because it showed companies how product work and customer work can merge when the problem is complex enough. The important shift was end-to-end ownership. A small team was not just advising from the side. It was working directly with stakeholders, building tailored applications, and dealing with massive data in the same loop. When that team can change the solution while the customer problem is still active, the feedback cycle becomes much faster and much more useful. That pattern outlived the original company context because the structure was stronger than the branding. New teams copied the same core idea in different markets. Put technical people near real users, let them build against actual constraints, and treat each deployment as both a customer win and a product signal. The same logic shows up outside defense as soon as adoption becomes the hard part. Shipping an AI feature is one thing. Getting it used inside a business process is another, and that gap creates demand for people who can learn from the field, make local calls, and feed what they learn back into the product. Titles may change, but roles with that mix still look like the original FD model. The point here is the pattern that made the early FD model durable. Stay close enough to the customer's problem to shape the solution, and close enough to the company to turn that lesson into something repeatable. That role was not just support work wrapped in a new title. The person in the field was changing the product with real customer pressure on one side, then carrying those lessons back so the organization could use them again. Each of those functions solved part of the problem, but none of them covered the full loop by itself. The field model worked because it joined implementation, customer understanding, and product feedback in one place. That question points to the deeper structure. The field team was only useful if it was tied to a platform that could absorb what it learned. The road, gravel, and paving language is about that connection between fast field work and the slower process of turning it into software that scales. This part is about how an early custom deployment starts rough and local, then turns into a repeatable product later. The contrast matters because it explains why some systems begin as hand-built solutions before they become scalable platforms. A solution can be very effective inside one organization and still fail completely outside it. That usually means the team has shaped it around a specific workflow, specific data, and specific constraints rather than a broad market. The field team begins by understanding how the work really happens, where it breaks, and what people need to do differently. From there, the first version is often a rough dashboard, a stitched-together pipeline, or a basic automation layer that is good enough to solve the immediate problem in that environment. That phrase captures the progression well. First, you build something narrow, practical, and maybe messy. Then you turn those lessons into a cleaner system that can travel farther. It separates the urgent job of making something work from the later job of making it reusable. The road metaphor separates a one-off fix from a repeatable platform. That difference explains how a customer-specific workaround can grow into something the whole product team builds on. A gravel road gets you through rough ground even when the path is imperfect. In product work, that means a solution built for one customer's exact need, good enough to solve the problem right now, but not yet something you would hand to everyone else. A paved highway appears after the same kind of request shows up again and again. At that point, the team stops treating it as a special case and turns it into shared infrastructure, so each new deployment starts from stronger base. That shift from custom road to shared highway is the key idea behind the FD origin story. It shows how close work with one customer can reveal a pattern that becomes part of the product itself. Field teams matter because they do more than pass messages back and forth. They sit close enough to the customer to shape the solution while the problem is still being understood. A lot of confusion comes from using the same words loosely. Before the model makes sense, the roles and responsibilities need to be named clearly. These are the people who work inside the customer environment, not just from a headquarters office. In this model, they're often engineers or technical operators who can see the real day-to-day constraints directly. Autonomy means the team can respond on the spot instead of waiting for approval from far away. That speed matters when the right move depends on details only the local team can see. Customers often describe a symptom first and the deeper need later. Discovery means working past the first request until the actual problem and the actual workflow become visible. The useful part of that idea is the balance. Give the team a clear goal, then let it adapt the method to the situation in front of it. That keeps the work aligned without forcing every decision through a central script. A boundary like this prevents confusion about who owns which decisions. If the field team can change something locally, it moves fast. If not, the issue needs to rise to the platform layer. Different layers need different scorecards. A field deployment should prove that people use it, it works reliably, and it saves time. A platform should prove that one improvement can travel across many customers without breaking the system. In that model, the field team is not a messenger standing between customer and engineer. It is doing several jobs at once, understanding the environment, building something workable, and carrying that knowledge into the product itself. That is the real source of leverage. When discovery and design sit in the same hands, the solution is more likely to fit the customer now and still be useful later. A useful way to understand this role is through a concrete deployment story, because the job only makes sense when you see how software meets a real workflow. The labels around this role have shifted over time, and different accounts use different terms. The important part is the recurring pattern. Someone sits close to the customer, learns the operational reality, and translates that into working software. A small scenario makes the mechanics easier to see because it shows the gap between a product on paper and a tool that actually gets used. Start with a customer whose work is blocked by scattered data and slow manual steps. A field engineer learns the process, then builds just enough integration or decision support to fit the existing environment instead of asking the customer to rebuild everything around the software. Before that kind of intervention, the team can describe the problem in general terms, but the real bottleneck is still hidden inside the day-to-day workflow. The complaint sounds clear, but it is still abstract. Until someone watches the work closely, The team may not know where the delay actually comes from. A generic product often misses the shape of the real process. So even a good feature can feel awkward if it does not match the way the customer already operates. When the software forces people to change habits, adoption stays weak. The friction is not only technical, it is also about whether the tool respects how people actually work. That complaint from headquarters can hide several different problems. Sometimes the feature is fine, and the real issue is the data shape, access rules, or the surrounding workflow design. Once the field team steps in, the situation changes from a vague product problem into a deployment that is shaped around the actual work on the ground. The system is tuned to the customer's real process, so the software fits the operation instead of sitting beside it as a separate tool. That matters because people evaluate the tool in the middle of real tasks. A demo can hide the hard parts, but everyday use exposes them immediately. Adoption becomes measurable in practical ways. Usage, whether tasks finish faster, less manual cleanup, and whether neighboring teams want the same system. That measurement also tells the company what is unique to one account and what could become part of a broader product. Field work is where custom fixes turn into evidence about general design. That distinction is the real value of the field role. The team is not only patching a single customer problem, it is testing whether the patch is a dead end or the start of something that can scale. The contrast here is between solving one customer's problem quickly and turning repeated solutions into shared product capability. The whole point is to see how field work becomes platform work. The useful idea is that early solutions are usually local and practical, not elegant. The lesson comes from recognizing when those local fixes are no longer one-offs and are worth turning into a broader pattern. The left side favors speed, fit, and survival in a specific account. The right side favors repeatability, cleanup, and scale because the goals shift from one successful deployment to a capability that can serve many deployments. That rough route exists because the customer cannot wait for a perfect design. After a few deployments, the team can see which parts of the terrain keep showing up, and those shared parts become candidates for abstraction and hardening. The strength of the image is that it joins two realities that often feel in tension. It respects the mess of early customer work while also showing how disciplined repetition creates a stronger base for the product. Enterprise work usually begins with something specific, messy, and immediate. Its value grows when those specific fixes are transformed into infrastructure that others can rely on again and again. Mission-type work needs a clear goal, a defined domain, and room for local judgment. That fit matters because the best move often depends on what the customer actually needs on site, not just on a fixed script. The company sets the target and the boundaries, then trusts the team to choose the right action in front of the customer. Sometimes the answer is a connector, sometimes it is a workflow change, and sometimes the real solution is to reshape the request or push a product improvement back upstream. That freedom matters because real customer problems do not arrive in a clean, standardized form. The team has to adapt to constraints, missing data, and shifting priorities instead of waiting for a perfect template. Different roles pull toward different outcomes. A sales engineer may care most about proving the feature. A consultant may care about handoff, and a product engineer may care about elegance. But an FD-style builder has to balance all three pressures at once. The incentives have to be set carefully, or the team will drift toward either a one-off patch or an overly pure platform view. The FD model tries to reward both immediate customer value and long-term product learning, so each engagement leaves the company in a better place. What changed after FD involvement tells you whether the role was real engineering support or just customer-facing support with a technical label. The useful test is whether the work altered the product, the workflow, and the evidence of adoption. A genuine FD function leaves behind changes you can point to. If nothing measurable changed, the title may have existed without the job being fully defined. The clearest way to judge it is to look for four kinds of change: the problem definition, the solution built, the way adoption was measured, and the product learning that came back from the field. Together, those tell you whether the work created feedback for the company, not just delivery for one customer. Start with the real failure point, not the surface request. Sometimes the issue sits in the workflow, sometimes in the data path, sometimes in adoption, and sometimes in the original assumptions about how the product should work. Then look at what the team actually changed. It might be a customer-specific bridge or integration, a new interface, automation around a task, or a direct product adjustment that removed the friction. Adoption has to show up in the real environment, not just in a demo. Good signals are operators using it, the target workflow getting completed, the pilot expanding, or manual effort dropping. The last question is whether the field work changed the product thinking. A strong FD loop brings back a repeatable pattern, a new requirement, or a sharper view of what part of the problem is universal. When that learning never comes back, the team may still be helping customers, but the organization is not getting the full benefit of the role. The field work matters most when it changes what the company builds next. This matters because the patterns spread far beyond one company. The interesting part is not the brand name, but the way a new role structure made technical work fit inside real organizations. A company does not have to invent a problem for it to create a useful model. Palantir gave a visible shape to a need that already existed, and once people had a name for it, they could copy the idea and adapt it. The labels vary from company to company, but the job shape stays familiar. The core idea is to place technical people close to the customer's real workflow, so the product gets built and adopted in the same conversation. When the technical person is near the problem, they can hear the constraints directly instead of guessing from a handoff document. That usually leads to faster decisions and fewer misunderstandings. Building in context means the team sees the process, the users, and the exceptions that matter. The software gets shaped by the environment it has to live in, not by an abstract idea of that environment. Every deployment does two jobs at once. It solves a customer need, and it feeds real information back into the product, so the next version reflects what actually happened in the field. That is why the job market language is so revealing. When a posting stresses discovery, implementation, and workflow change, it is usually describing this same hybrid role, even if the title sounds unfamiliar. A good shorthand for the FD model is a two-step balance. Solve the customer's problem first, then turn the repeated pieces into platform value. That balance is what separates a one-off workaround from engineering that scales. A simple memory aid helps keep the metaphor grounded. It points to the order of work, which matters more than the exact wording. The gravel road stands for speed and usefulness in the field, even when the solution is rough around the edges. Paving comes later, after you've learned which parts are stable, reusable, and worth investing in as product or platform work. That line captures the real job description. The work has to solve a specific customer problem, but it also has to leave behind something the company can reuse, which is why strong field teams are measured by both delivery and reuse. The remaining question is adoption. If the model makes sense, why didn't it spread everywhere right away? The answer sits in the incentives, the organization, and the fact that this kind of role only works when product, sales, and engineering all support it. This part explains why the forward-deployed model remained obscure even after it was working in practice. The important issue is not whether the idea existed, but why it did not turn into a public template right away. The question after the last rule is a good one. If the approach worked, why didn't everyone copy it at once? That gap between what works and what spreads is the main thread to watch here. The answer has three parts. From the outside, the model was difficult to observe, difficult to reproduce, and not especially useful for the company to publicize once it already had an advantage from using it. The first barrier was simple. A lot of the work happened in environments that were not meant for public description. When the setting is closed, the operating model stays hidden with it. Defense and intelligence customers create a special problem for visibility. If the work, the workflow, and even the people involved are sensitive, then the method cannot easily be turned into a public example that others can copy. That is why enterprise software means more than software for large companies. It has to fit approvals, permissions, audits, legacy systems, and existing work habits. And an AI deployment in that setting changes the job itself rather than just adding a feature. A consumer product can broadcast its value in public and let the market judge it. A sensitive deployment often cannot be shown that way, so the internal learning is real, but the outside world never gets a clean picture of it. The second barrier is strategic. A company can have a useful internal model and still decide that publicizing the method would weaken the advantage it already has. Once a workflow produces results, the details behind it become part of the moat. Revealing the machinery can invite imitation before the rest of the market has even understood why it matters. Field autonomy makes that even clearer. The person closest to the problem needs room to decide locally, and that kind of judgment is effective precisely because it is flexible, not because it fits neatly into a sales pitch. If the company's value came from blending software, services, and on-site judgment, then the operating system was not just support around the product. It was part of the product's protection, so there was little reason to expose it early. That distinction matters. An idea can stay quiet without being absent. In this case, the model remained private because sensitive customers, internal efficiency, and competitive advantage all pointed in the same direction. The next question is what the role looked like in practice. The labels changed over time, but the working pattern was consistent enough to recognize. The team did not arrive with an empty notebook and a generic plan. It arrived with a mission, then started by learning the customer's real problem, the operational constraints, and what the users actually needed. That is different from generic consulting and different from normal product engineering. The goal was not a polished deck or a broad feature set. It was the smallest change that could survive the customer's real environment. A workflow can look like a software issue on the surface and still be a process issue underneath. Rekeying data, broken handoffs, and low trust in outputs are the kinds of details that reveal where the real failure sits. The engineer's job is to map that workflow, find the breakpoints, and design a narrow fix that works in context. That fix might be a data join, a permissions change, a small interface, or one automated step that removes friction. A comparison makes the pattern easier to see. On one side is a vague operational problem. On the other is a working workflow that can be used, trusted, and improved. The point of the comparison is to show the shift from description to execution. The job changes when the problem becomes concrete enough to build against. Before the team arrives, the customer usually describes the issue in broad terms and patches work together by hand. Afterward, the workflow becomes specific enough to measure, repeat, and turn into reusable product learning. Mission-type tactics fits this well. The team gets a clear objective and room to adapt the method to the local terrain, because enterprise environments are never perfectly standardized. The next issue is copyability. A role can look simple from far away and still be extremely hard to reproduce without the same conditions around it. A company can copy a title in a week. Copying the conditions that make the title valuable is much harder, and that is a major reason the model stayed limited for so long. Reproducing the pattern requires several ingredients at the same time. Missing even one of them makes the imitation fragile. The product has to be flexible enough to reshape in the field. If the software cannot bend without breaking, the engineer has no room to solve the real problem. The customer side also has to be complex enough to justify embedded technical work. Simple, standardized buyers usually do not need this kind of close-in problem solving. The team needs engineers who can switch between building and listening. That balance matters because the best technical answer often comes after the engineer understands how the customer actually works. Leadership also has to value each deployment twice, once as revenue and once as learning. Without that mindset, the organization will underinvest in the messy work that produces the insight. Trust is the last requirement and often the hardest one. The engineer has to be close enough to the work to shape it from within, not just comment on it from the edge. That trust becomes even more important in human AI workflow design. The real question is where automation should help, where people should stay in the loop, and where the system must defer to judgment because the operational risk is too high. The same logic shows up in LLM systems. A useful application needs retrieval, permissions, task routing, output controls, logging, fallback behavior, and human review, because model quality alone does not make the workflow reliable. That is where eval-driven deployment comes in. The test is not whether the model sounds smart. The test is whether the whole system can do the customer's job reliably, and if not, the fix may belong in the prompt, the data, the UI, the workflow, or the governance layer. The idea became more visible once the market changed around it. When more companies hit the same adoption problem, the structure of the role became easier to name even though the work stayed difficult. Later AI products made the gap more obvious. A model could be impressive in a demo and still fail inside a real organization, which forced companies to confront the distance between output and adoption. That is why the language spread across companies. The title varied, but the structure stayed the same. Place technical talent near the problem, let them learn in the field, and feed those lessons back into the product. A job posting can reveal this pattern very quickly. The wording often tells you whether the company needs someone to discover the problem, shape the workflow, and carry the learning back into the roadmap. When those responsibilities appear together, you are usually looking at the same structural need that Palantir solved early. The title may be new, but the job underneath it is familiar. A final rule ties the whole pattern together. The useful way to think about it is through the conditions that let the model survive and spread. The model stayed quiet because its value depended on things that are difficult to show publicly: sensitive customers, internal efficiency, and a real operating edge. Those are the kinds of advantages that work best before they are widely explained. The deeper lesson is that these roles began as a practical way to make software work in hard environments. Later, they became a blueprint for enterprise AI adoption, especially where the gap between a demo and a deployed system is still large. The next step is to see what changed once that hidden operating model started showing up as visible business value. Palantir's real payoff was not just a recruiting story. It was a way to turn embedded fieldwork into a product that could scale. The important question here is how the company's customer-facing engineers helped create the platform itself. The model stayed hidden for a reason, but its effects were visible in how the company built software. The origin story makes more sense when you treat the field organization as part of product creation, not as a side story about hiring. FDSEs were the people who sat inside customer accounts, dealt with messy data and broken workflows, and built the first versions that actually worked. What they learned in the field fed back into the core code, so the accounts became a source of product development. That is the key shift to keep in mind. The customer work was not extra effort around the product. It was the mechanism that generated the product's shape. Enterprise software often gets sold before anyone fully understands how it will fit into daily operations. In a setting with legacy systems and high stakes, the only reliable teacher was the live deployment itself. The contrast here is simple. Once an engineer is embedded with a customer, the whole feedback loop changes. The work stops being distant guesswork and becomes direct observation of what breaks and what can be standardized. The easiest way to see the effect is to compare a detached product team with one that sits inside the account. The second arrangement learns faster because it sees the bottleneck in real time. Before the embedded team arrives, the customer lives with disconnected systems and vague success measures. Afterward, the workflow becomes specific, adoption becomes measurable, and product learning becomes concrete enough to reuse elsewhere. That is why the model scaled commercially. The engineer adapts the software to the customer's real workflow first, then turns the useful parts into something the next customer can inherit without starting over. People sometimes flatten the role into a loose hybrid of consulting and engineering, but that misses the point. The job exists because the deployment problem is uncertain until the software is actually inside the environment, and someone technical has to discover that in place. The pattern had a repeatable shape, and that shape is what made it useful beyond one customer. Once the same operating pattern appears again and again, it starts to look less like a one-off engagement and more like a template. The value came from a small set of recurring choices in how the work was organized. Each one reduced distance between the engineer, the user, and the product team. Small pods move faster because communication stays tight and responsibility stays visible. That makes it easier to respond to what the account actually needs instead of waiting on a large delivery machine. Working with the people who run the process matters more than talking only to a sponsor. The engineer needs the operators because they know where the work slows down and where the real constraints live. The platform was not a generic app sitting by itself. It became valuable when a standard foundation supported customer-specific layers that matched the way the organization actually operated. End-to-end ownership means the same people carry the problem from diagnosis through adoption. That continuity matters because the person who understood the pain also sees whether the fix really landed. The crucial feature is that one deployment can teach the whole company something useful. A lesson that leaves the account and enters the core product turns isolated work into shared capability. That is the difference between a services shop and a product company. One solves a single customer problem and stops there. The other captures the lesson and folds it back into the platform. A useful way to picture the role is as translation between vague business language and a concrete operational fix. The engineer turns a broad complaint into a workflow that can actually be built. A request like better analytics is usually too broad to act on directly. The real task is to find the bottleneck underneath it, because the problem is often reconciliation, handoffs, or data cleanup rather than analysis itself. The test changes once the tool goes live. Now the question is whether people stop using the workaround, whether decisions get faster, and whether the customer wants the next workflow built on the same foundation. That is why field autonomy matters so much. The engineer needs enough freedom to adapt in the moment, but also enough discipline to bring the useful pattern back into the product for everyone else. The scale story only makes sense once the field work is tied to reusable product capability. When deployment creates product knowledge, the company can grow without treating every new customer as a completely separate invention. By the time the company reached public market scale, the important fact was repeatability. Foundry was no longer just a custom project. It had become a repeatable deployment engine that customers could actually adopt. The market context matters, but not in the simplistic sense that a role alone justifies evaluation. The deeper point is that the role helped create the product capability that made growth possible in the first place. That same structural problem shows up under many titles today: forward deployed engineering, solutions engineering, applied AI engineering, and similar hybrids. The name changes, but the underlying need is the same: closing the gap between a platform and a working deployment. This is why labor market analysis has to be careful. Title counts can miss demand when labels are fragmented, and compensation analysis can mislead if base salary is not separated from bonus, equity, and location effects. The deeper lesson is that the model scaled because every deployment served two purposes at once. It solved the customer problem and exposed what the product needed to become next. Once one company proves a pattern like this, the next question is how it travels. The spread into the broader market is where the idea stops being a company-specific tactic and starts becoming a wider operating model. This part traces how the forward-deployed model escaped its original setting and became a reusable pattern in tech and AI. The point is to understand why one company's operating style started showing up in many others. The real question is not whether the model worked, but how it traveled. Once you see the path of spread, the rest of the chapter makes a lot more sense. Diffusion here is not one invention suddenly copied everywhere. It moves through people carrying habits with them, investors recognizing a useful pattern, and a new AI market creating the same deployment problem again. A useful way to think about spread is through people, not just ideas. When engineers move, they often bring an entire working style with them. Former engineers did not only take experience on paper. They carried a way of working, stay close to the customer, build in context, and treat deployment as part of the product rather than something done after the fact. That distinction matters because the real asset is behavioral. Go to the field, learn the customer's problem in context, adapt quickly, and feed what you learn back into the product team. When that mindset moves into a new company, it changes how engineering works. A simple example makes the shift concrete. A startup goes from shipping a dashboard and waiting for complaints to putting engineers into customer meetings, watching real usage, and rewriting workflows because the neat internal design does not match the messy process on the ground. That is the first route of diffusion. The practice survives because the practitioners move. Capital was the second route. Once investors saw the same adoption problem repeat across companies, they started giving the pattern a name and treating it like a deliberate strategy rather than a one-off quirk. Venture firms are very good at turning recurring behaviors into memorable labels, and those labels travel fast. A fund even adopted the concept in its own name, which shows how far the idea had moved beyond a single company and into the broader startup conversation. Investors care because this model solves a common startup problem. A product may be strong, but if it is hard to adopt, the sale is not finished when the contract is signed. The real work is making the product fit the customer's messy environment. That changes the company's economics. In a self-serve software business, the ideal is that the customer can buy and use the product alone. In a forward-deployed model, the engineer who helps translate, integrate, and reshape the workflow is part of how the product actually reaches value. The fastest wave of diffusion came from AI itself. AI companies ran into the same gap between impressive capability and reliable real-world use. Large-scale AI systems created a fresh version of the same issue. The technology could look excellent in a demo, but teams still had to make it work inside real organizations with real constraints. That mismatch shows up in permissions, audit rules, latency limits, legacy systems, and messy exception handling. Powerful software does not become dependable infrastructure just because the model is smart. The same pattern appeared across labs and AI-enabled software companies. The model might answer a question, but the business needs the right question, the right context, and a system that fits real operational constraints. A model can produce a plausible answer very quickly, but that alone does not make it useful in a company setting. The harder job is choosing the question that matches the operational decision the customer actually needs to make. Context matters because the same prompt or action can be useful or useless depending on what data and history the system can see. The output also has to fit the workflow, so it lands at the right point in the process instead of living as a disconnected tool. Even a good answer can fail if it violates access, review, or compliance rules, so governance becomes part of the design. Reliability is the final test. If people cannot trust the system on a normal workday, it does not matter how good the demo looked. That is where the modern forward-deployed engineer fits. The role is not sales, and it is not classic consulting. is the engineering job of turning model capability into something a team can safely use. A comparison helps make the change visible. The same product can look very different once an engineer is working directly at the boundary between the system and the customer's workflow. The table on the board shows what changes when the engineer becomes part of the deployment. Focus on the transition from a working idea to a working system. Before the role appears, the product may be correct in theory but stalled in practice. Afterward, the workflow gets redesigned, guardrails get added, and success is measured by actual usage, operator approval, and fewer manual workarounds. That feedback also tells the product team what should become standard product, not custom support. At this point, the earlier ideas stop looking separate and start fitting together. Origin story, field autonomy, product learning, and AI deployment all point to the same operating logic. The role emerged from a real need. Advanced software had to be deployed into messy organizations, and ordinary product delivery was not enough. Field teams often have to act on local information before a central playbook exists, so the work depends on judgment close to the problem. The engineer needs enough freedom to solve the immediate customer issue without waiting for every decision to travel back through the company. Deployment itself becomes a discovery process because real use often reveals what the customer needs more clearly than the original request did. Modern AI systems are more than model calls. They include orchestration, retrieval, permissions, monitoring, and integration, and each piece has to hold up in production. The real product is often the division of labor between people and the model. So the design question becomes who does what, when, and with what oversight. A serious launch depends on structured tests. Good demos matter, but reliable production depends on measurement. Once AI acts inside business processes, safety, review, and traceability stop being side concerns and become core engineering requirements. Palantir matters here because it made the pattern legible before the wider market had a name for it. The details changed over time, but the underlying idea stayed the same. Engineers close to the customer, turning ambiguity into working systems. Those roles made customer-embedded engineering easier to see. The important part was not the title itself, but the expectation that engineers would work in high-stakes environments and turn operational needs into functioning software. Palantir is the chapter anchor because it showed a repeatable principle. When the product is complex and the customer environment is even more complex, the company needs someone who can live at that boundary. A practical rule falls out of all this. The forward-deployed model spreads when software is too powerful to deploy on its own and too tied to operations to be left alone. A short way to say is that powerful software does not deploy itself. It needs engineers who can work inside the customer environment, translate operational pain into product changes, and turn usage into learning. That sentence captures the whole argument well. The model becomes a reusable advantage when deployment, learning, and customer fit are treated as one job instead of separate stages. As AI spread, the need for this boundary-spanning engineer showed up in more places at once. Labs, enterprise SaaS, and startups selling complex systems into complex organizations. The titles vary, but the hiring logic is converging. The next step is to see how one especially visible AI company adopted this logic and branded it in its own way. That will show how a pattern becomes an industry standard once it gets a name and a home. OpenAI takes the same embedded engineer idea and reshapes it around deployment, evals, and product feedback. The title matters less than the operating model it reveals. A role can look new on paper, but the real question is whether it solves the hard deployment work. In AI, the hard part is usually not naming the job. It is getting a model to survive contact with real users and real systems. A call center brings all the messy conditions that a polished demo hides: accents, noise, latency pressure, and constant edge cases. A model only counts as ready when it performs against those failure modes and keeps improving after traffic starts. That is the kind of gap forward-deployed engineers are meant to close. They sit close enough to the customer to make the system real, not just impressive. The reporting matters because it shows the function growing from a small team into something repeatable. Once a role becomes an operating unit, It is no longer just ad hoc support. It is part of how the company works. The key move is that the engineer works inside the customer's environment and defines success with the customer's actual workflow in mind. That turns the deployment into a measurement system, and it also feeds lessons back into the platform itself. The pattern becomes clear when you shrink it down to a few steps. A messy customer problem pulls the engineer into the field, and the field work turns into product learning. The sequence matters because each step solves the weakness of the one before it. The engineer does not stop at a prototype. The work continues until the deployment is usable, measurable, and able to teach the core team something new. Older software teams often split product, sales, implementation, and support into separate lanes. The FD model collapses those lanes so one person can discover the problem, build the first version, and carry the lesson back instead of letting it vanish at handoff. The useful comparison is before and after the embedded engineer enters the picture. That makes the role easier to see as a system, not just a job title. A before and after comparison makes the shift concrete. The same customer need can look vague from the outside, but with an embedded engineer, it becomes a solvable technical system. Each row shows the same idea in a more mature form. The change is from guessing and demo-driven judgment to structured evaluation, reliable rollout, and lessons that improve the product for everyone. That table is doing more than describing one company. It introduces the recurring themes behind the role, which show up again and again in different industries and teams. An origin story matters when it shows a one-off exception turning into a repeatable pattern. OpenAI did not invent the idea from nothing, but it adapted it to the shape of an AI lab. The engineer gets a mission, not a rigid script. That leaves room to improvise inside real constraints, which is exactly what fieldwork demands. Autonomy matters because waiting for approval at every step slows the path to value. The person closest to the problem needs enough authority to act while the problem is still live. A request is rarely the whole problem. The deeper work is to uncover the operational need underneath it and turn that into something measurable and buildable. The role covers the full life cycle, which is why it has so much leverage. Each phase feeds the next, so the engineer stays involved long enough to prevent the work from breaking at the boundary. A prototype only proves that an idea can work once. Production asks a different question. Can it keep working under pressure, at scale, and with real users depending on it? Deep embedding is not the finish line. The real value appears when the customer work produces something the product and research teams can use. So the lesson changes the platform instead of staying trapped in one account. That voice model case is useful because it shows two gains at once. The customer gets a workable system, and the company gets a clearer map of what to improve next. The feedback loop is what makes the role more than implementation. It turns one deployment into a source of repeated learning, which is the real strategic value. Follow the loop from top to bottom. The field generates the tests generate insight, and the insight reaches the product team. Once the improvement ships, it goes back into broader customer use and starts the cycle again. That phrase means the hardest part sits where the model meets the messy human world. Deployment is not a single handoff there. It is a continuing process of adaptation and support. OpenAI's job descriptions reflect a wide span of responsibility. The work runs from understanding the problem to shaping the system, getting it into use, and carrying the results back into evaluation. The hiring logic follows the market. As AI moves from pilots to real deployments, companies need people who can work across the customer boundary and convert ambiguity into something operational. Palantir helped formalize the original pattern, but OpenAI shows how it changes when the product itself is evolving quickly. In one setting, the engineer operationalizes a system. In the other, the engineer helps define what the system should become. That plain English version gets to the center of the story. OpenAI scaled the role because the company needed a way to connect model capability, deployment reality, and product learning into one continuous motion. The same pattern appears again once the story moves beyond frontier labs. Ramp and Salesforce show how the role matures when more companies start treating deployment as a core product function. Ramp and Salesforce show what it means for an FD model to move beyond a narrow AI lab pattern. The point here is to see whether the same structure starts working in mainstream products where trust, deployment, and customer needs matter just as much as model quality. That test matters because a pattern confined to frontier labs may just reflect a special environment. Once it appears in fintech and enterprise software, it starts looking like a repeatable operating model rather than a one-off implementation detail. Ramp and Salesforce sit in different markets, but they point to the same bottleneck. Strong models are not enough on their own. The hard part is turning a promising product into something customers can rely on, with real users, real constraints, and a real production environment. Ramp and Salesforce sit in different markets, but they converge on the same operating model. Put technical people close to the customer so deployment becomes part of the product, not an afterthought. In fintech, shipping software is only part of the job. The real work is making the tool fit approval chains, accounting practices, policy controls, and the day-to-day habits that finance teams already trust. Enterprise software has a different shape, but the constraint is the same. The system has to be usable across large organizations, which means administrators, operators, and business users all need a workflow they can understand and maintain. That is why field autonomy matters. The engineer is close enough to see the failure, test a fix, and send the learning back into the product, while the team still works from clear intent rather than central control. Ramp is a good example of the pod approach. A small, cross-functional team can move quickly on customer-specific problems without turning every request into a one-off exception. A pod usually owns a slice of accounts or rollout motions, so the team has enough independence to adapt the deployment while still staying organized around shared mission. Because the exact internal rules are not fully public, the useful way to read Ramp is as a concrete example of a broader pattern. Stay near the customer, move fast, and turn each deployment into product learning. The starting point is the problem the customer actually has, not the wording of the ticket. That keeps the team focused on the real constraint instead of polishing an abstract feature request. Small changes matter because they remove friction without creating extra complexity. In deployment work, the best fix is often the one that gets adoption moving with the least disruption. Each rollout teaches the team something about how the product behaves in the real world. That learning is valuable beyond the customer at hand because it improves the next implementation too. Once a pattern stabilizes, it should not stay trapped in services work. The goal is to turn repeated fixes into product features, so the same solution does not need to be rebuilt every time. That structure fits fintech because the blocker is usually trust, not interest. A finance team may like the idea already. What it needs is proof that the workflow fits policy, reconciliation, and approval rules. In LLM-era systems, the failure rarely lives in one place. The model, the retrieval layer, the orchestration logic, the integrations, the guardrails, and the monitoring all have to work together, and the FD sits across those layers to find the weak link. A common failure mode is a workflow that works technically but creates too much noise for real users. Tightening the rules, adding review for edge cases, and clarifying exceptions can turn a fragile demo into something finance teams actually keep using. That sequence is the heart of the fintech version of the role. Discover the problem, tailor the deployment, measure it in real use, and feed the lessons back into the roadmap. Salesforce shows the same idea, becoming more formal inside enterprise SaaS, where the company is trying to make field engineering repeatable rather than dependent on a few exceptional people. Programs like Momentum and Ready in 6 suggest structure, not improvisation. They point to a company trying to train FDs in a common way, so the role can scale across many customers. When onboarding covers architecture, customer patterns, deployment constraints, and escalation paths, the company is turning field knowledge into something teachable and repeatable. Enterprise SaaS brings a different set of constraints, so the role changes shape. The important question is not just whether the system works, but whether it stays understandable, governable, and reusable at scale. Most customers already have a platform and want something that fits into it cleanly. The deployment has to respect that reality instead of demanding a redesign of their whole stack. Administrators and business owners need to know how the system behaves and how to control it. If they cannot govern it, they will not trust it in production. AI features also have to live inside existing permissioning and audit rules. That is where deployment can succeed technically and still fail organizationally if support boundaries are unclear. The company has to learn from each deployment without letting every customer become a permanent special case. Reusable patterns matter because they keep the business from accumulating custom engineering debt. That is why a program like Momentum matters. It suggests a deliberate deployment motion with shared training and shared expectations, so the organization can repeat the same quality of work across customers. In that model, the FD is helping define the reusable path, which integrations are standard, which guardrails are required, how onboarding works, and how success is measured after launch. The clearest way to see the role is to compare a deployment before and after FD involvement. The differences show up in clarity, workflow design, reliability, and adoption. Before the FD shows up, the customer may like the idea but not have a workable path forward. Afterward, the problem is translated into a specific workflow with clear constraints and measurable outcomes. The table makes the shift easier to see. Each row moves from vagueness to specificity, from demo behavior to production behavior, and from guesswork to measurable adoption. That is why the role is broader than a technical account manager. The FD is part of the machinery that gets software into use and keeps it working once it is there. Ramp and Salesforce are different, but they are adapting the same core model to different business realities. The industry changes the emphasis. The underlying loop stays the same. Ramp's fintech setting pushes the role toward workflow precision and trust, while Salesforce pushes it toward onboarding and governance across large organizations. The shape changes, but the embedded engineer is still close to the customer. Those 5 moves are the recurring pattern. Proximity reveals the real issue. Production testing proves whether the workflow holds up, and the product gets better because the lesson is carried back upstream. That is also the practical meaning of mission-type tactics here. The company sets the outcome, then trusts the field team to make the local decision that unlocks adoption where the customer actually lives. Once companies outside Frontier Labs adopted the model, the role stopped looking niche. Hiring demand now reflects a need for engineers who can move across product, deployment, and customer context without treating those as separate worlds. One useful rule captures the whole pattern. Serious FD programs are serious about turning deployments into product learning while still keeping operational control. That rule separates real FD work from ad hoc support. The company wants each customer engagement to teach the product team something useful without letting the system drift out of control. That is the practical meaning of the second wave. The model spread because more companies hit the same bottleneck from different angles. Proving a product can work in principle matters less than making it work inside the customer's own environment. The next step is to look at what changes inside the company itself once FD becomes a standard part of shipping AI. The stack, the workflow, and the product team all start to reorganize around deployment. This part separates the surface of the FD role from its operating logic, so the difference between older and newer versions becomes clear. The point here is not just that a new job title appeared. The important part is that the work became visible, repeatable, and concrete enough for other firms to imitate in their own settings. Those two eras sound similar on paper, but the day-to-day work is different. One grew out of constrained government deployments and custom-built systems, while the other sits on top of LLM APIs, agent frameworks, and faster pilots that mostly require composition and hardening. That difference matters because titles can hide a lot. The label stays familiar, but the technical environment and the shape of the job can change quite a bit underneath it. The older version of the role is about working inside a difficult environment and adapting to its limits. The key idea is close embedding plus constraint. The engineer is there to make progress where the customer already lives and works. In that model, the FD is not just a technically fluent seller. The role is closer to an engineer on the ground, learning how decisions actually get made in government or intelligence settings where the data, rules, and politics all shape what is possible. Once the engineer is inside the customer environment, the problem stops being abstract. The work has to fit the reality of the organization, not an idealized product demo. The first job is to understand how people actually move information, where handoffs fail, and what counts as good enough in a mission setting. That is why this looks like field autonomy, a small team close to the problem, adapting as it learns. A simple comparison helps organize the change before the detailed table appears. The basic question is how work, data, and adoption behave once someone is embedded to redesign the process. The pattern across these rows is that the FD turns scattered activity into a usable system. Decisions become faster, data becomes operational, tools become fit for the task, adoption becomes real, and the lesson stops staying local. The failure was not always the raw data itself. More often, people could not trust the workflow, find the right information fast enough, or turn analysis into routine decisions, and the FD was there to close that gap. The newer version keeps the embedded posture, but the technical center shifts. The main job becomes designing an AI workflow that can sit inside real products and real organizations. Now, the engineer is often building around model APIs rather than inventing every layer from scratch. The challenge is still technical, but the emphasis is on making the model useful inside a live customer system. The stack is more standardized, so the work shifts toward choice and coordination. APIs, frameworks, evaluation tools, observability, and deployment patterns become parts of one controlled system instead of separate inventions. That change shows up quickly in how the work is run. The sales motion, the workflow design, and the deployment discipline all move faster and become more concrete. When the value is easier to demonstrate, the relationship can compress. Teams do not need as long to see whether the AI approach is worth pursuing. The conversation changes from model capability to system design very quickly. The real question becomes where the model belongs in the workflow and what it should actually touch. At that point, important decisions are about task boundaries. Some steps should be automated, some should stay human, and some need approval gates or special routing so the process remains safe and usable. A polished demo is not enough once the system has to work on real tasks. Repeatable evaluation is what tells the team whether the deployment actually holds up in the customer environment. A system that can act can also fail in more expensive ways, so reliability becomes part of the design from the start. Governance is not an afterthought when the model is allowed to do more than chat. The triage example makes the change visible. The organization moves from scattered messages to a structured intake flow, retrieval, drafting, human review for sensitive cases, and logging that exposes uncertainty, which is the real transformation. Even with the newer stack and faster pace, the role still follows the same deeper pattern. The next points are the parts that did not change. The important continuity is cultural, not technical. Even as the stack changed, the roles still needed the same instincts about proximity, judgment, and learning from real use. The FD has to stay close enough to hear the real complaint, see the workaround, and understand the gap between the official process and the actual one. Distance would remove the signal that makes the role useful. The role also needs room to make local decisions quickly. Constraints are still present, but the engineer has to navigate them without waiting for every answer to come back from the center of the organization. The best FDs do more than make one deployment succeed. They notice repeated failures, recurring patterns, and missing pieces that should become part of the product for everyone else. That is the through line from the older model to the newer one. The surface changed, but the operating logic stayed the same. Get close to the customer, solve the real problem, and carry the lesson back into the product. Palantir made a basic lesson legible. Some software problems only show up when an engineer works inside the customer's world. Modern AI companies inherited that lesson and adapted it to a different stack and a faster market. For job seekers, the name on the posting is less important than the work behind it. Whether the role is called Forward Deployed Engineer, Applied AI Engineer, or Solutions Engineer, the market still values people who can sit between product, deployment, and customer context. That is the practical test. If the organization expects all four of those moves, then it is using the FD model, even if the title is different. The next step is to examine what changes inside the tech stack, the workflow, and the product team once this kind of embedded engineering stops being unusual and starts becoming the normal way to deliver AI.